Now we move to the synthesis filter bank. Just as for the block transform case, we can also get a corresponding formulation for the synthesis filter bank. For the synthesis filter bank, we can now also write the reconstructed sequence x hat of n in terms of blocks with index m and phases n, and obtain the synthesis upsampling and convolution as we've seen before in the previous lecture. That's given by equation number 8. And we have it here with some still to be determined gk. We can now use vectors for our sequences of blocks to simplify this equation using a vector for our reconstructed signal and for our cave synthesis filters. And we start again with looking at just one filter. So what we're doing here is we're using vectors for sequences of blocks and vector for our reconstructed signal and for our cave synthesis filter. Now we can rewrite our synthesis equation as given here, where L is the length of the synthesis filters. So the inner sum is a convolution where we now no longer have our phase index n, because we now have output blocks instead of samples. So we can turn the convolution into a multiplication using the Z transform, and this is what we're doing here. And now we can extend this notation to our bank of n synthesis filters using our subband vector YZ and the synthesis polyphase matrix. Since the output is the sum of all subbands, we obtain our polyphase matrix by collecting all our polyphase, in this case row vectors of our synthesis filters gk of c, into a matrix, such that the outer sum of the above equation turns into a matrix multiplication. So we have this here, and where each row of G of C now contains one synthesis filter. And this is the synthesis polyphase matrix. Observe that for this polyphase matrix, the indices for the subbands K and for the phase N are in reversed order when compared to the analysis polyphase matrix that we've seen before. In conclusion, again, we turned the mathematically very complex operation of upsampling and synthesis filtering into a mathematically very simple operation with the multiplication of the subband vector with the polyphase matrix, and we have here our reconstructed signal.